Cool. Hi, everyone. Super excited to be here today. We'll be sharing Spotify's experiences with scaling Backstage. And we'll discuss how to tailor Backstage to your organization's needs. I'm Jack Palmer. I'm a staff engineer at Spotify, working across all things Backstage.
And I'm Avantika. I've worked at Spotify for over 2 years now, and a lot of my time has been dedicated to getting Backstage to deliver value at scale. It's truly my favorite topic, and so I'm back here again at Backstage Con, to talk about how we can scale Backstage effectively to achieve high performance at a high-performing org like ours.
To get the most out of Backstage, then it should be the home for your engineers. The first place they look for a high-level overview of their responsibilities. A snapshot into the status of the fleet of components. You need to make sure that Backstage has the right integrations and is displaying the right information an engineer needs when they need it. And if it isn't, your engineers need to be able to contribute as effortlessly as possible.
And if you aren't showing the right information to your Backstage users and making it relatively easy for them to contribute to it, they're going to start leaving the platform and visit it less each day. And now you've come a full circle, back to those DevX problems for which you set Backstage up in the first place. Your engineering knowledge is siloed with various engineers and masquerading as job security. The key really is to have the right strategies in place for Backstage to perform at a high level your organization requires. So at Spotify, we recognized that engineers are often looking for information, but can struggle to find it because the source can sometimes be in a completely different engineering division of Spotify's business. Backstage being that single pane of glass for various platforms scattered across your business is certainly the best bet for a central hub of distributed information. Backstage Search, as you all know, has been a fantastic way to streamline this knowledge discovery, but sometimes you really need to have that right keyword or service name to get the result you're looking for. And sometimes you have to scroll through a long list of results to find the one that you're really interested in. Could we improve this somehow? Because all the information your Backstage instance centralizes makes it really suitable to be used as data for AI.
And this is what we did internally at Spotify with a tool that we called Iyer. Iyer is an AI assistant powered by large language models and fed with our own Backstage data. By leveraging AI, you naturally encourage your organization to invest more in Backstage, integrate more plugins, more data, with results being more accurate and more detailed. One of the biggest challenges a developer faces is distractions. Someone pinging them on Slack or even tapping them on the shoulder. Taking them out of their workflow to answer a question that is actually documented somewhere, but just not easily found. Engineers are discovering knowledge from across the organization without having to disrupt other engineers. And we find that 86% of Spotifyers who are active on GitHub are actually using Iyer. There's a lot more detail we could dive into about adding AI on top of Backstage. To learn more, go to the KubeCon talk, Leveraging Internal Knowledge, Building Iyer at Spotify, which is at Wednesday, 12 o'clock.
So that's just one example of how we've made Backstage a bit more useful for our engineers. And before this talk, we heard from others in this community about how Backstage has been really successful for them. And you might recall that when you first set Backstage up, it was for a certain organization size, a manageable number of software components. Things are rolling, docs are being centralized on it, and the instance is growing with many plugins. All that glow up is making it really successful and popular, like that teenager you knew back in high school, right? So developer productivity is skyrocketing, Backstage usage is exploding, and it's all happening so quickly that before you can take a breath to enjoy it, your previous known platform requirements have drastically changed and its performance is degrading. In the words of the wise DJ Khaled, you, sir, are suffering from success. So Spotify's Backstage, has over 50,000 components and 100,000 APIs in the software catalog, and our monorepo has over 200 custom plugins. And we've started seeing a lot of issues at this scale, right?
So suddenly, as owner of a Backstage in your organization, you start getting requests to add more plugins, more squads onboarding, adding their components, and additional engineering disciplines joining the product. But as your Backstage usage scales, so does your issues. Well, that was certainly our experience at Spotify. With more users come more requests and features and changes to Backstage. Even if engineers are independently contributing this, the chances are that you're reviewing the PR. The catalog suddenly slows down and engineers are complaining about stale components and the time it takes to update. Delivery is taking longer and longer and the code base is getting increasingly complex. How exactly can you prepare for your engineering needs today and in the future? So these are the three main focus areas we believe you need to address to achieve a high-performing Backstage. Frictionless development for maintainers and internal contributors, scaled development of Backstage backends, and a catalog scaling strategy.
Right, so Backstage's greatest asset is any feature that is missing, for example, can be addressed simply by contributing to it, usually by means of a plugin. So if your squad wants to visualize important metrics or data across their fleet of components, they should be able to do so without any friction. For frictionless contribution, you need distributed collaboration. Increased collaboration, though, can often be problematic for Backstage maintainers. So if you have 1,000 of engineers contributing to your Backstage instance, you now have hundreds of pull requests to review. You have to keep an instance available and up to date for this growing user base, right? So if your users are stuck in traffic trying to cross the bridge, they might just get fed up and turn around or try to find a new destination. Now we don't want that. So as a maintainer, you really have a lot of pressure on you to solve this problem. So for example, you own all these files in the repo that gets the most commits, right? So whenever a plugin owner adds a new front-end plugin, as a code owner, you get requests to review changes to the front-end app. And this is where the plugin's added and its APIs and routes are registered. Now, if a plugin owner adds a backend plugin, you get requests to review the file in which they register the backend plugin code. And additionally, you'll have to review that yarn.log file as well, which has all the updates to the Backstage dependencies. Ouch. Jack, please tell me there's a better way to do this.
Yeah, there certainly is. So you can enable autonomy for your engineers by utilizing the new front-end and back-end systems in your plugins. While the front-end system is still in alpha, the back-end system is stable and encouraged to be used today. So we previously discussed this at past BackstageCon events, and these systems encapsulate all the wiring within the plugins themselves. By utilizing the extension system, plugins can register themselves to specific parts of Backstage without touching that area of the code. The only time a plugin owner would touch the app or the backend would be to initially install the plugin. So this means that your approval is only needed when that plugin is introduced and significantly reducing your workload. You give autonomy back to the plugin owners and allow them to develop and iterate without blockers. While we do not recommend migrating to the front-end system today, we're excited to be able to work on the future of it. Spotify are dog food in the new front-end system and are driving it forward, but also taking on the responsibility of adhering to breaking API changes during the alpha stage. And if you want to hear more about these systems, make sure to visit the KubeCon talk, The State of Backstage in 2025, Wednesday, 4:15, which is hosted by our wonderful open source maintainers. So let's take a look at what the future looks like for contributors. So on the left-hand side, you can see this is your app.tsx file. And usually people are coming in here having to register individual routes, and in this example here, there's some business logic in the element. So there's some sort of condition where they either render a page and they don't. And you can see how this business logic has bled over outside of your plugin, and it has to be integrated directly within the app. However, with the alpha system, or the new front-end system, instead, you can encourage your developers to write their plugins in a new way, where they can utilize extensions to own their own plugin wiring. On the right-hand side, you can see how a plugin is using a page blueprint to add a page to Backstage, all from within its own plugin. As a Backstage owner, you can even create your own blueprints and control where in the app plugins can integrate themselves into. With the new front-end system, you responsibly scale your code base by dictating where plugins can be integrated within the app, and plugin owners implement their own business logic within their own area of code ownership.
Be wary, though, because now you might end up needing approvals from plugin owners when you're updating their dependencies as part of your Backstage update. But not to worry, these updates can be simple with the use of Yarn plugin. Once you install Yarn plugin, replace all of your dependency versions to the Backstage reference protocol. With this change, Yarn will resolve all the Backstage dependencies using the version declared in backstage.json. So there you are. You're no longer being blocked on approvals while updating Backstage, and all of your Backstage dependencies are compatible with the Backstage version in backstage.json. How magical. Look at how small these upgrade PRs can look as a result. So we implemented these improvements and found that the overhead of maintaining Backstage considerably reduced. Plugin owners are developing on Backstage with autonomy and greater control. But we also found that without the maintainer gatekeeping, we had increased the risk of shipping Backstage with a broken backend plugin, one that might even bring the entire instance down. Subsequently, we started investing in strategies to make our Backstage backend deployments more resilient. At the end of the day, as a maintainer, even if you don't own the plugin code anymore, you're still completely responsible for the instance being available.
So if you're running a backend instance that also runs all the plugin backends, then you will have experienced an issue where one plugin has resulted in Backstage crashing and unable to start up. So this is a serious problem for high-performing organizations that are utilizing the most out of Backstage, as the platform has become critical for your engineers. So imagine these engineers responding to a major incident, and they're relying on Backstage, but it's down. And it's all because of one infrequently used plugin that is misbehaving. So to combat this, Spotify has introduced the plugin boot strategy into the open source. So as you can see here in the app config, you can specify what strategies you want your plugins to behave and when they boot up and how the backend will then handle these. So in this example, by default, we're allowing any plugin to just, if it crashes, that the backend will continue and still spin up with that plugin being down. But however, you can then call out and have explicit rules for these plugins that you see as high priority, such as something like the catalog, where this will abort the backend if it fails. So this has some advantages over a standard rollback you would get normally without this strategy, because it keeps your main branch up to date. So if you had rollbacks, then you may have contributors who are like, they're putting commits on top of main, keep shipping, but then actually it never makes its way to prod because it's broken. So with this, you can keep main shippable, and those low priority plugins will fail to start up. But taking this further, you can then use scaled backends, and this is what we do at Spotify. So we do something that looks similar to this, even though the plugin specified here is not necessarily how we do it. But you can see that deployment A has got some plugins like the app, the auth, the proxy. And deployment B probably has the more critical ones to you and to your engineers, so catalog, search. And then deployment B, maybe that's got tech docs and scaffolder. Then we wrap it all up with an authenticating proxy and discovery API so they communicate to each other. But this gives us benefits of being able to horizontally scale any of these backends for those plugins that require those extra resources. But then it's also got increased availability as well. So in this case, if scaffolder goes down, then you've still got catalog and search, and you've got auth running. So you've got your engineers who are still using the platform. And yes, it's not great that you can't create anything in your organization, but it's not a blocker for a lot of your engineers. And it also comes with security improvements as well. So in the case that one of these plugins, maybe it's got a malicious package in it, it limits the chance of a supply chain attack. If only one of these plugins uses this one malicious package, previously the entire backends would be vulnerable to that package. But now it's isolated into these smaller deployments.
So more and more of your organization, so once you've kind of implemented this bit, right, like your organization is going to start adopting Backstage and be developing on it without any frictions. And as your adoption grows, your software catalog will scale, and those existing catalog configurations might fail to keep up. These will primarily start manifesting while components are being ingested into the software catalog. When you first set Backstage up, before you did all this crazy stuff for scaling, you likely set your ingestion strategy up this way. So let's assume all of your repos are hosted on GitHub. You would have used a GitHub app for your source control integration, and then you probably created a catalog provider to discover new catalog info files at regular intervals through that integration. You also set up a processing interval to refresh the entity location so that they can stay up to date. And all of this was working until you hit the scale. Once your GitHub repositories and orgs have grown rather large, your catalog headaches can also really increase. You might be getting bombarded with distressed users on Slack about the catalog not being up to date. Your catalog configuration settings are causing the ingestion to keep running into GitHub rate limits. We saw that, didn't we? But good news, we can fix that by adopting a more scalable catalog strategy.
So the logical fix of this is to use incremental ingestion. So here we're distributing the pull-in over a set duration. But this can be slow to complete and resource intensive with a constant stack of entities on the processing queue. It doesn't actually guarantee to fix these rate limiting issues because as your entities increase over time, as you scale again, you'll need to expand the duration of ingestion so that you're below the rate limit, and this is a constant battle that you'll be tweaking. We find that the catalog will then become slower and slower to respond to updates. So instead, we recommend using a push ingestion strategy. So this is fast and light, and it actually offloads the work of detecting changes to your source rather than to the catalog. And this is what we use at Spotify. But what exactly is our strategy?
What is our strategy? The push-based ingestion strategy we use no longer relies on discovery. We only create entities through the scaffolder or the catalog import feature. Entities are refreshed through change events emitted by the GitHub Events API. And just in case we miss any events, we reconcile the catalog against GitHub like once every 24 hours. And with this strategy, we've overcome those GitHub rate limiting issues and seen a remarkable improvement in our catalog's performance.
So here's a graph of what this actually looks like. And on the left-hand side, you can see the pull strategy. So there's 80 entities being processed a second here. But if you look carefully, these are actually unchanged. So this is just completely redundant work for the catalog to be doing. So you can imagine the lag this is adding to the catalog, that if you've always got, let's say, 80 entities a second on your processing queue, when you actually get to that changed entity, then it's going to be sitting behind at least 80 of these, if not more. But comparing that to a push-based strategy, you can see that the unchanged process entities have gone down to 0. And it only ever receives these changed events. So the catalog is doing much less work than it was previously doing. Also, you can then see the reconciliation where this is being distributed over 24 hours, and this is capturing those maybe any missed events that might be there, but it's much lower value, and as I pointed out, kind of distributed over a longer time. We've also found that this is a reduction on resources as well, and the CPU usage drops 90%. And also, looking at the database operations, we've gone from 9,000 operations per minute to 1,000 per minute. That's a significant saving, and you can see how this strategy can scale for the future of your organization.
Yeah, so those are some of the few ways in which we implemented a high-performance Backstage at Spotify, and hopefully these will work for you too. So quick recap on everything we talked about today. Start with enabling developer autonomy and distributed collaboration with the new front-end and back-end systems. Use Yarn plugin to streamline your Backstage updates.
And investigate horizontally scaling your backends and splitting out those important plugins into its own infrastructure for resilience and code ownership. And then also using a push-based catalog strategy. So no longer having to worry about rate limiting and lightning-fast catalog processing by utilizing the events from your version control. Cool, thank you very much for your time today. We're here all week if you want to discuss this in more detail. Thank you.
Thank you.